This is all right, and this is going to be the last topic for this chapter, by the way. This is going to be the last topic. So that means, of course, what happens after you finish your last topic in a chapter? You guys already know, right? Right. I'm going to take a test. Oh, I think you hit the wrong symbol there, Ava. So the parentheses is supposed to go the other way, I believe. I believe it's supposed to go. Let me see here. I think it's supposed to go this way. There you go. That's the way it's supposed to go. All right. So all this whole chapter has been about, I don't know if you noticed this or not, but it's basically applications of derivatives, right? If you're realizing what the big thing of this test is going to be about is still just like the last chapter, right? Last chapter was all about techniques of taking derivatives, power rules, chain rules, right? Taking derivatives, making sure you take the derivatives correctly. In this chapter, you're applying those said derivatives, meaning you're still getting problems that you're going to have to take the derivative of, but now you're trying to find some context of like why you're finding the derivatives of particular problems. And this is the last section. This one is a major one of like just straight up word problems, right? Of when we would apply these derivatives. So here we have a 15-foot ladder that's resting against the wall. The bottom is initially 10 feet away, right, from the wall and is being pushed towards the wall at a rate of 1/4 feet per second, right? How fast is the top of the ladder moving up the wall 12 seconds after we start pushing? Now, we drew this picture last time, right? We saw that initially it's 10 feet away, right? The ladder is 15 feet long, and the height at which the ladder is resting against the wall is something we don't know. It's a variable that's changing. And then we listed out some other things, right? We're trying to find out the rate at which the top of the ladder is moving up the wall. So we're finding out what the change in the height is with respect to time. So we're looking for dh dt. And they tell us that the rate at which the base is changing is 1/4 feet per second, but it's going towards the wall, which means the base is actually getting smaller. So the rate is actually a negative rate, right? And we talked about this last time. Negative and positive is really just a sense of direction, right? If you're taking physics, right, you kind of understand that, right? If your gravity is negative in your equation, then objects that are traveling up are going to be positive in that equation, but you could also switch them around. And it's basically just how you define your axes, right? If you want right to be positive, left to be negative. I mean, in this particular case, it just makes sense that it's negative because B is getting smaller and smaller, so the ladder is getting closer and closer. So the rate at which this thing, the distance, the base of the ladder is from the wall is going to be negative, okay? Now, we drew this out so that the wall is straight up and the ground is flat, which makes a 90-degree angle. And then when we placed the ladder down there, it created a 90-degree right triangle. That's redundant, knock me. It created a right triangle. I didn't need to say the 90-degree part. So you guys noticed last time that if you have a right triangle, right, we can go ahead and write out the Pythagorean theorem that relates the base, the height, and the hypotenuse together. So that's what we have here. B squared plus h squared is equal to 15 squared, right? That's a nice equation. And then once you have an equation that relates those variables together, the base and the height, which is what we care about because we have the change in the base and the change in the height that we're working with, to get those changes, all we need to do now is take the derivative. Now, it's important though when you take the derivative, you understand that for these rate problems, you're taking the derivative with respect to time most of the time. And what helps to see that is basically the rate that you're dealing with is over a unit of time, right? So I'm going to go here and take the derivative of this equation right here. Take the derivative with respect to time, right? Now, when you do this, please make sure that you don't forget the chain rule. Don't forget the chain rule. And that's a very common thing when you're taking derivatives, because you guys are like probably looking at this like that's an easy thing to take the derivative of. B squared is just going to be 2b, and you tend to just leave it like that. But that is not done. We also have to take the derivative of the variable inside with respect to whatever variable we're looking at. So in this case, the derivative of b with respect to t is just going to be db dt. That's why that has to be there. And I've made this comment before in the past, right? Why didn't we do it before when we have x squared and I took the derivative of x squared, right? d dx of x squared would just be 2x, wouldn't it? But we talked about this, right? Remember, we are doing the inside. It just ends up being that the inside is going to be dx dx, and we just don't bother writing dx dx because dx dx just, cancels out, and you're just left with 2x. In this particular case, though, dB dt is not going to cancel out. dB dt is important, so you have to make sure you include that along the way. All right, 2b dB dt plus the derivative of h squared. Derivative of h squared is going to be 2h. And again, don't forget the chain rule. dh dt, right? And then what's the derivative of 15 squared? Please don't write down 2 times 15 to the first power. 15 squared is just a constant. Derivative of a constant is just going to be 0. And there we go. We have our new equation that relates dB dt with dh dt, right? And our ultimate goal, remember, is to find out what dh dt is. Our ultimate goal is to solve for this, right? Is to solve for this. Now, there's an issue here, right? They got 3 variables that we don't know, or 3 variables that we need to plug in for. And we know one of them. We know dB dt. We can plug in that's negative 1/4 feet per second. But we don't know what the b is or what the h is. Can you guys tell me what a common mistake is for this problem? What do you think is a common mistake of a number that we should plug in for b? Anyone have any ideas? All right, Monica's getting ahead of me there, but yeah, you're almost quite right. They give us the number 10, don't they? And they give us 10 as the base. But here's my question. After 12 seconds is where we're supposed to find out the rate at which the height is changing. After 12 seconds, is b still equal to 10? And that's what I'm trying to tell you guys right now. The most common mistake is people will plug in 10 in for b, but 10 is not your base after 12 seconds. Could you imagine this? The ladder is changing at a rate of 1/4 feet per second. It's getting smaller, right? So every second, it's decreased by about 1/4 of a foot. So after 4 seconds, it's no longer 10 feet apart, right? The ladder is no longer 10 feet away, I should say, not apart. The ladder is no longer 10 feet away after 4 seconds. After 4 seconds, it's now 9 feet away. Can you picture that? Every 4 seconds, that's what this 1/4 feet per second is saying. Every 4 seconds, it's getting closer to the wall by 1 foot. So does anybody know after 12 seconds, how close is this thing now to the wall? Right? The ladder is this thing is no longer 10 feet apart. Right? This ladder is now some distance from here to here, right? Where it started, right? It was 10 feet apart from here to here. But after 12 seconds, it's now changed. And Monica's saying 7. Brian's saying, wouldn't it be 7? And that's right, guys. It would be 7. You guys want to elaborate how you guys got 7? That is correct. Your new base now is going to be 7 feet after 12 seconds. And that's a tough one to explain for some people. See, the height's changed as well, by the way. The height used to be down here, but now actually this dotted line is drawn poorly. If you push it closer, it should be higher, so it should be something like this. There we go. That's a better, it doesn't really matter how accurate that is, but that's the better idea, right? It used to be 10 feet away, but now it's 7 feet because it's been moving for 12 seconds. But how do you know that it's 7 feet? Is there some mathematical way that we can show that? Well, we need to be able to prove what was this distance right here. How can I calculate how far it's traveled after 12 seconds? Well, if you think back to algebra, right? Do you guys remember this formula? Distance is equal to rate times time. You guys remember that one? Usually it's acronymed as DIRT, right? Does that sound familiar? Distance is equal to rate times time. How far something travels is equal to the rate at which it's going times how long it's been traveling. So if someone's driving 45 miles per hour and they've been driving for 1 hour, they have traveled 45 miles, right? If someone's going 60 miles per hour and they've been traveling for 2 miles, wow, that doesn't make sense. If someone's been traveling at 60 miles per hour and they've been traveling for 2 hours, they've been on the road and traveled a total distance of 120 miles, right? And that's the idea here. The rate at which this ladder is getting closer and closer is 1/4 feet per second, right? How long has it been traveling for? It's been traveling for 12 seconds. That means that the distance that this thing has traveled is 3 feet. And that 3 feet is this part right here. That's what you find out from there. So 3 feet doesn't go in for the base. 3 feet does not go in for the base. 3 feet tells you how far the ladder has traveled from here to here. But remember, the base, right, is the distance that the ladder's base is from the wall. So that being 7 feet, that's what your base is in this case. So I know that at 12 seconds, right, B is going to be equal to 7. B is going to be equal to 7. So that right there helps me plug in for this value. Now, Monica, I'm going to go back to what you said earlier, right? Plugging in a number in for B into the first equation, which is this guy right here, to help us find H is what we're going to do right now, right? Is what we're going to do right now. So if B is equal to 7, right, what is H equal to? Well, we just plug into that equation up here. And you're like, which equation do I know to plug into? And that's, you got to be careful with, right? I'm not going to be plugging into this equation. This is the equation that's going to help me to solve dH dt. I'm going to plug into this equation. I'm going to call this my secondary equation. Okay, this is what's going to help me to find out what H is, so I can figure out and plug into this guy. Okay, so let's go ahead and do that real quick. I'm going to rewrite this equation again. This is going to be B squared plus H squared equals to 15 squared. B in this case is going to be 7 squared plus H squared is equal to, what's 15 squared, guys? 15 squared is 225. Thank you, Monica. I appreciate that. 225. You were right. And 7 squared is going to give me 49. So 49 plus H squared is equal to 225. H squared is going to be equal to 176. And I take the square root of both sides. H is going to be equal to the square root of 176. And I don't think that simplifies. I'm going to leave it like that. Some people like to write down the decimal. I say write the decimal at the end of the problem. That way you'll be carrying, you don't have to worry about carrying significant figures throughout the problem, right? You can leave it as a radical. Let's see here. Does it simplify? Square root of 176. And it does not look like it simplifies. And I'm not going to reduce it, right? I'm not going to bother reducing it. You can, but it's not necessary. So with that being solved for, H equaling to square root of 176, I have now found out what this value is. So that's the thing. You're pretty much, when you're dealing with these word problems, right? You're trying to find out, list out the variables that are going to be in play. Highlight the variable that you're looking for. And then that leaves the remaining variables that you need to find based off of the word problem that they give you, right? So they tell us actually the base without actually telling us that the base is 7, right? They tell us that it's 10 to begin with, but they tell us that it's traveling at some speed, so we know that it's going to be smaller by 3 feet. And that's how we found out that it's 7 feet right there. Once you find out the base, we can use Pythagorean Theorem to find out what the height needs to be, because the hypotenuse is particular value as well. Okay? So we're going to go ahead and just plug in these things into this equation now, right here. And remember, our ultimate goal is to find out what dH dt is, right? That's our ultimate goal. We're trying to find out what dH dt is. So I'm going to plug in all these values here. So I have here, give me some little space here, 2 times B, but we just found out that B is equal to 7, right? Times dB dt being negative 1/4 feet per second, plus 2 times H, and we just found out that H is the square root of 176. That's a terrible number. Or not a terrible number, it's just not a pretty number. Times dH dt. And this, of course, is all equal to 0. And then this just becomes an algebra problem. You're just solving for this single variable with a bunch of numbers around it, right? So we just go ahead and multiply everything together, right? 2 times 7 is going to be equal to 14 times negative 1/4 is going to give me negative 14/4, right? Plus 2 times the square root of 176 times the variable that I'm solving for, dH dt, is equal to 0. And just do some algebra at this point and just simplify and, just simplify. Let's go ahead. I'm going to go ahead and add the 14/4 to the other side. So I have here 2 times the square root of 176 times dH dt is equal to 14/4. I'm going to divide both sides by 2 right here. And I'm going to end up with the square root of 176 dh dt is equal to 7 over 4 because I divide both sides by 2 right there. Divide by the square root of 176, and I have here dh dt is equal to 7 over 4. And in the bottom, of course, because I'm dividing by the square root of 176. And that's your answer, guys. Of course, that doesn't really make much sense. Like, I don't understand what that number is. So if you really want to know what that number is in the sense of what this problem is doing, just plug it into your calculator. All right, I'm going to have here 7 divided by, and I'm going to put this in parentheses, 4 times the square root of 176. Oops. Put that in parentheses like so. And I get here a decimal value here of dh dt equaling to 0. And if you're ever questioning how many decimals to go, just go to 4. It makes it a little bit easier. Most places like 3 decimal places. I say go to 4. It doesn't hurt. If you only go to 2 decimal places, it's it's gonna be kind of okay. In physics, they go 3 sig figs, so I'll leave it up to you. If you want to do it, I'd say more decimal places the better. 1.1319. If on the tests on the AP exam, which by the way, you guys will be taking the full exam in May. If you wrote down 1319112,137, right? And you'll say, knock me, that last number is a 3. Why'd you write down a 7 there? They will automatically round to the ones that they want to round to for that rubric. Meaning, if they are grading and they say that the problem needs to be rounded to the nearest 3rd decimal place, the person who's grading your AP exam is just going to round it to the 3rd decimal place for you. I believe. I could be wrong on this. It's been a while since we've actually taken the full test, but I believe that is the case. But I know this, though. If you write down a lot of decimal places, most of the times they're just going to give you the points as long as it looks like it's somewhat close to your answer. Okay, so don't stress out on that part. In fact, don't stress out on any of this stuff. I'm hoping you realize, like, this lengthy problem seems like a lot, but I'm hoping you see that it's just if you think about it like a jigsaw, right? You have a bunch of these pieces, and you're just trying to find out where each of these pieces go. Okay, you're just trying to find out where these pieces go. So once you find out what B is, that goes in there. Once you find out what H is, that goes in there, right? Once you find out what dB dt, that goes in there, right? And you're just solving for what's left. Speaking of what's left, I had about a couple kids who just left. Oh, this thing tells me who's ghosted me. Oh, wait, they came back. Oh, maybe they have internet connections issues. But anyways, I'm going to pause it here. I'm going to ask you guys can you guys go on a Pear Deck real quick and just give me a thumbs up and thumbs down on how you feel about this problem, right? How do you feel about this problem? Does it make sense of what we were doing? And if it doesn't make sense, be honest with me. We're going to do more problems, but I just need to know, how do you feel right now? How do you feel right now? We haven't done enough examples, I'd say, for you to just be a master of it, but at least let me know, do you feel somewhat comfortable with this? And be honest with me. If you don't, then you don't. We'll just do more problems. And I'm going to be honest with you. You guys all had green thumbs up anyways. We're going to do more problems anyways, because I like to hear myself talk about math. Okay. A lot of you guys are average in here, and that's perfectly fine. With a few students who are very uncomfortable with it. No one's like exceptionally great at it. So I think that's a good sign that we should do a couple more problems, okay? So we're gonna go ahead and do a couple more of these problems here. Let's go ahead and zoom down here, and let's get another example up. Okay, let's do another example here. Let's go with this one over here. All right, you guys ready? Let's take a look at this problem. I'll give you guys a second to write this down. By the way, I had a student in my other period ask me, do I need to copy down the word problems? And I don't know, guys, it's your notes, whatever you guys want to do. If you don't copy down the words, then make sure you understand what the question is asking from you when you go back to look at your notes. I don't know. I never know how to answer those questions. Do I need to write down all these words? I mean, they're your notes. Whatever you. I'm not grading your notes. A hypothetical cube grows so that the length of its sides are increasing at a rate of 4 meters per minute. You guys imagining that hypothetical cube yet? How fast is the volume of the cube increasing when its sides are 4 meters each. So, chance to earn some points. Chance to earn some points. Here's a blank screen. List out, from what's given here, give me a drawing and list out the values of some variables for me. Or actually, no. Hold on. Give me a drawing. Label the variables for the sides for me. Yeah, that's better. And then with those same variables, give me the names of the variables for the rates of the side and the volume. Yeah, you guys got this. Let's just try that out. Let's try that out. I want to see you guys draw. Let's start off with just drawing the picture for me. Can you guys draw a picture for me of what it is that we're talking about? Because that is step one. That is step one. Yeah, let's start with that. And then if you feel comfortable with that, can you guys give me an equation that relates the volume with its sides? The volume with its sides. Remember, we're dealing with a cube, and a cube is this 3-dimensional rectangle, but all the sides are equal to each other. So you don't have to worry about length times width times height, because that's what volume is, right? The length, the width, and the height are all going to be the same, right? The length, the width, and the height are all going to be the same. So make sure you try that out there. Oops, no. Not what I wanted to do. That's the one I want. Okay, it's you. There we go. All right. I'm gonna take a look at some of your drawings here. Okay, I'm not gonna lie, some of your drawings are immaculate. That is pretty good. That's pretty good. Calvin, did you draw that by hand? Perhaps. Yeah, well, that's pretty good. I'm going to say that is pretty good. All right, let me go ahead and give these people some points. No, I have no skill. I mean, it's there. You got it on there. All right, so we got here. We got David, we got Jocelyn, Alvin, Monica, Emily, Brian N, Shirley, Brian V, Joe, Max, Ava, Gracie. I'm forever just going to have that in my head now, Gracie. It's either Grace or Gracie. Both are acceptable, and I'm not okay with that. Diana, Jeffrey, got you. Angela, why'd you delete your response, Angela? I'm going to give it to you anyways, Angela. You don't need any more points, though, Angela, but I'm going to give it to you anyways. Leslie, good start. Leslie R. There you are. And Fatima, got you. Look at you. All right. Give you those points. We got the commitment because you guys are committing to these. All right. So you guys should have at least gotten this far. You should have drawn yourself a cube. And if you don't know how to draw a cube, that's okay. Just draw something that looks relatively close to a cube. It's understandable that you guys don't have the same artistic skills that I have, Just kidding. I'm a terrible artist. But yeah, there's my cube, right? Normally for a rectangular three-dimensional shape, right, we would label this the length, the width, and the height, right? But the fact that they tell us it's a cube, right? The length, the width, and the height all equal each other. So I'm not going to use length, width, and height. I think I'm going to use something better. I'm just going to call them sides, right? They actually say it right there. The sides of these guys right here. So instead of L, I'm going to call that a side. And instead of W, I'm going to call that a side. Instead of H, I'm going to call that the side as well. So they all are the same lengths, right? This side right here is the same length as this side, is the same length as that side, right? That's what makes it a cube. All the sides are equal to each other. So normally, when I'm looking at the volume of a rectangular shape, I'm supposed to take the length times the width times the height. But since those are all the same, right? It's just the same thing as the volume is going to be equal to the side times the side times the side. I see it already. Some of you guys already have the equation written down. Volume, in this case, is equal to sides cubed. I was thinking cubed, and I wrote a 2. I'm going to pause there. Are you guys okay with what I have done so far to get this equation? Does it make sense? Why am I even looking at the volume of this? Monica's saying yes, right? I'm hoping you guys understand. I read this problem. How do I know I'm supposed to calculate or how do I know that I'm supposed to relate this with volume? And they say it in the problem. There are other just because it's a three-dimensional shape, though, it doesn't mean that it's always going to be volume. Sometimes they might say instead of volume, they might use words like surface area. And that's a tough one for some kids because they might not have covered this when they had like a geometry class or an IM2 class. Do you guys know how to calculate the surface area of a cube? This is a side note. Don't even write this part down. But do you know how to calculate what's the surface area of a cube? Any ideas? What would the surface area be equal to? If I needed to write down the surface area for this cube. Anyone got clues? Any ideas? Length times width times 6. Yeah, that's it, Monica. There are 6 sides, right? And when you're calculating surface areas, you're calculating the area of each of the faces. So there's one face, there's a second face, there's a third face, right? And then, of course, there's the back side, the left side, and the bottom side. So there's 6 sides in total. So that's why it's times 6. And they're all the same, right? They're all the same. Oh, God, knock me. You're just erasing everything. I'll just leave that on there. So if the surface area then, if you didn't know how to do this, you would just say, oh, it's side times side, right? That's going to be length times width. So it's going to be side squared for that, and then you multiply that by 6. But we're not doing that for this problem. Just keep that in mind. Sometimes they do have you calculate how much the surface area is changing. In this particular case, though, they're asking how much the volume is changing, right? So writing that down, right? Let's write this right here. The sides are increasing at a rate of 4 meters per minute. So I'm going to write that down. ds dt, the rate at which the sides are changing, is equal to 4 meters per minute, right? 4 meters per minute. How fast is the volume of the cube increasing? That's what is being asked of this problem. So that means that the rate at which the volume is changing is being asked, and that's what I need to find out. And I'm hoping you guys are seeing this piece out pretty well here, right? S and V, we needed to find an equation that relates the two, and that's right here. Volume and the sides is right there. But to get the rate at which they change, I just need to take the derivative of this and take the derivative of this with respect to time, right? dv dt is what's going to be the derivative of the volume with respect to time right there, dv dt, which is what we're trying to find, by the way. And s cubed, please, please, please don't forget the chain rule. Don't forget the chain rule. Chain rule. Chain rule is important, guys. S cubed is going to give me 3s squared ds dt. So remember, our ultimate goal is to solve for dv dt, which is, it's already done for. I don't need to do any algebra. dv dt is already by itself. I just need to start plugging stuff in. I already know that ds dt is going to get plugged into here as 4 meters per minute. What else do I need for this problem to help me solve for dv dt? What's the last variable that I need to plug in for? S, Brian, that's right. I need to know what s is. Do we know what s is? Let's go back and read the problem. Do they tell us what the side is? What's the measurement of the side? Oh, Monica's getting ahead of me. that will become, yeah, that is going to be right. But before we get to that far, the sides are going to be what? The sides are going to be equal to 4. And we're not doing anything where we're changing it, right? We're looking at it at exactly when s is equal to 4. So I'm going to plug that in for s right here. So I have all these values here. I'm going to go ahead and plug these in to my equation so I can solve this here. dv dt is going to equal to 3 times s, which is 4, squared, right, times 4 meters per minute. Right? Again, where did I get that from? 4 meters per minute comes from there. And this 4 comes from the fact that they tell us that, oh, by the way, if you're going to put down units for everything. This is 4 meters. Right? 4 meters. You don't need to put down units, but units are nice to help you see what your final units are going to be in, because this one is actually going to be a little bit different. All right, this one's going to be a little bit different here. So bring this up over here. We have now dv dt is equal to, let's go ahead and plug this into our calculator. We have, turn on your calculator, 3 times 4 squared times 4 again. And that's going to give me 192. 192. And what do you think the units are going to be for this? 192, what are the units for this? Anyone got any ideas? It's the rate at which the volume is changing over time. And the time that we're dealing with is in minutes, so it's going to be something per minute. Who's got the top one? Monica's going with meters squared. Meters squared, remember, is a measurement of area, right? Area is your units squared. What's the units for volume? What's the units for volume? It'll be cubed. That's right. Meters cubed. Now, how can you tell? By looking at the units that are here. Well, 4 squared is going to give me 16, but that also squares the meters, right? There's a meter squared there. But the meter squared here is going to multiply with the 4 meters per minute. And when you multiply these units, meters squared times meter, that's where the meters cubed comes in. And the minutes just goes in the bottom there. But that's it, guys. That's going to be your answer. 192 meters cubed per minute. Meters cubed per minute. All right. How you feel? You feel okay? Does this one not as bad? Does this one seem okay? Or you feeling worse? You feeling better? Show me on that slide with the thumbs up, thumbs down. Show me where you're at. Do you feel better? You feel worse? Update your thumbs up, thumbs down for me real quick, just so I can see where you're at. If you're still thumbs down, just move it like move it at a lower level so it's not in the middle of the thumb, so I know that you're still in there checking in. It's kind of weird, right? These problems are a little bit strange, but I don't know. It's not too bad once you get the hang of them. The hard part, I'd say, for a lot of my students when they do these types of problems is they don't remember the equations for the things that they're dealing with, right? They don't remember how to calculate the volume of a cube, and that's okay. And they don't know how to calculate the sides of a right triangle. And again, that's okay, because it's been a while since you've looked at these things. And what my tip is going to be is, if you forgot these equations, for now, just look them up. If you don't know what the surface area of a cube is, or the surface area of a rectangular shape is, you're at home right now, just Google it up. And there's no shame in that, because those equations are older equations that you might not have been practicing. Okay. It's not until you get the skill of developing or seeing how you can calculate those equations on your own. That's like from one level to the next. So don't let it stress you out that if you don't know the equation for something, right? Eventually, what level I want you to get to is that you don't have to memorize these equations. I want you to get to the level where you can calculate or find those equations on your own. But for right now, just look them up online. Just look them up online, and that's what I'm going to show you for this next problem. Okay, so let's go ahead and looks like some people are feeling way better now. The people who had their thumbs down before are still at the same level of thumbs down. So I'm going to have to do some practicing here. Some people moved a little bit up, a little bit down. along the way there. But it looks like on average, we have a little bit more people feeling comfortable with this. So that's better. That's better. I'm going to go ahead and clear your screens. Give me 1 second here. I'm going to go ahead and clear your screens. And then let's go to the next problem. We're just going to keep doing more and more problems until we feel more and more comfortable with this, okay? So let's go on to the next one. Moving on to the next one. Nah, that looks zoomed in enough. Let's go to this one right here. Copy. Let's bring you over here. Paste. All right. Maybe zoom out a little bit, Naki. There we go. Whoops. Gotcha. There we go. Okay, so water is leaking from a cone at a rate of 2 cubic centimeters per second. If the diameter and the height of the cone are both 10 centimeters, how fast is the water level dropping when the depth of the water in the cone is 7 centimeters? So right off the bat again, can you guys draw a picture of a cone for me? So make this cone upside down because it's leaking out of the tip. So the cone is going to be vertical. It's going to be upside down, right? The base is going to be this flat part up top, like the little cone cup, and this water is leaking from that cone at a given rate here. So here's what I want from you guys. Okay, here's what I want from you guys. Can you guys draw the picture for me? Label with all the variables that you can think of, and give me the equation for the rate at which all the stuff is changing. Like, what do you know and what are you trying to find? That's a lot asking from you here. So don't leave it with just the picture. Give me some variables that go with that picture, and then give me the d what dt, and the d is equal to, in this particular case, it looks like 2, right? It's a 2, and then give me the d what dt is that we're trying to find. So let's go ahead. I'm going to set up a 3-minute timer. Yeah, 3 minutes is good. Give me a 3-minute timer. Let me see where you're at on your drawings and your variables for this one. Go ahead and put this on the screen. So give me the drawing. Give me the variables with your drawing. And yeah, let's see where you're at. I'm so dehydrated today. It's so cold and so dry. I'm drinking water nonstop and I still feel like dehydrated. I don't know if you guys feel the same way. But yeah, I feel terrible. Maybe that's just me. I don't know. Maybe you guys feel okay. Oh my God, David. That's a very nice ice cream cone. But that's not going to help you in this problem because the thing that's inside the cone doesn't actually go all the way to the top, right? The thing inside the cone only goes up 7 centimeters, and the cone itself is 10 centimeters tall, right? The cone itself goes all the way up to 10 centimeters, but the liquid that's inside only goes up to 7 centimeters. So be careful with that one. Max, and Joe, draw your cone the other way. Actually, it doesn't matter actually if you draw it that way, but remember the water is leaking out of the tip. So yeah, it could be leaking out of the top of your cone. I guess. Who am I to judge? Maybe you can just rotate it. Can you rotate on there? I don't actually know. I feel like you could. Beautiful, Joe. Beautiful. Well, it's been about 2 minutes. You guys should have your cone drawn. Start labeling it with your variables, and then I want to see what you're going to put down for what your variables are equal to. Right? What are your variables equal to? This one's going to be a little bit more difficult as a problem as a whole, but we'll see. We'll see how you guys feel. So nice, you've labeled some stuff. Now tell me, if we're gonna be as a class here, are you guys okay if we say the height of the cone or the height of the liquid inside the cone? You guys okay with using the letter H? Right? Using the letter H maybe is okay. And I don't know what else we need. Oh, and then they tell us that water is leaking at a rate of 2 cubic centimeters per second. That's a rate. That's a d something dt. You guys tell me what that d something is. And it's equal to it leaking at 2 cubic centimeters per second. All right. I see a bunch of names and I see a bunch of drawings in here. I'm going to give you guys some points before I move on real quick here. He's got that beautiful drawing in there already. Jeffrey, same thing as his beautiful drawing. David just doubled down and just stuck with this drawing of that ice cream, even though we're talking about volume could be ice cream, but that ice cream should not be topped off, right? That ice cream should be in the cone because the cone is 10 centimeters and the level at which the volume is only 7 centimeters high. So still a beautiful drawing, but I'm not judging too harshly. Brian B has got a nice drawing there. Monica as well got a nice drawing. I like the colors in there. Brian N has a beautiful drawing and then has a crazier drawing off on the side there. What happened there, Brian N? You have some crazy looking art that goes off on the side there. Angela L. Nice. Don't forget to tell me the level at which the volume is inside the cone when you draw that. Joe, that's beautiful what you have in there. Calvin has a very intricate drawing. It looks like you got 2 cones going on there. I need to take a look at that. See what the heck that is, Calvin. I'll take a look in a second. Jocelyn E. Got you. Max, I got you. Max, that's an interesting you got the rate down, 2 cubic centimeters per second, but I don't know what that variable is that you have in front of that is. Oh, the rate. That's not a variable, that's a word, knock me. It says rate. I got you. You got Ava. Nice. I appreciate the color coding on the liquid there. Leslie R. I see your cone. Don't stop there. Keep going. Like, list out the variables that are with it, Leslie. Grace. Good. Got the color of the cone. You got the color of the volume that's inside the cone. Same thing for you, Fatima. Very nice. I appreciate it. Shirley has her cone tilted at a side and having it leak out that way. That's... I like that, though. I like it. It does not specify that it's actually leaking out of the bottom. So you're drawing it so it leaks out that way. I like it, Shirley. It's a clever drawing. Emily, I like your drawing. That's good. You got the level inside. That's beautiful. Emily C, I got you. And Diana S, same thing. You got your cone, but don't forget to, go a little bit further than just that. All right, you guys. Surely you guys are committed to learning today. Put in this effort to go. Let's take a look at what we got here, okay? Let's take a look at what we got here. So we have here a cone that is leaking at a rate of 2 cubic centimeters per second. If the diameter and the height of the cone are both 10 centimeters, so the diameter and the height are equal to each other on this cone, how fast is the water level dropping when the depth of the water is 7 centimeters, right? So there's a bunch of information here. Let me just draw my cone out first. So my cone is going to look something like this, right? You guys have seen a cone before, right? And it kind of goes down to a tip, like so, right? There's my cone, right? And they tell me that the diameter of this cone is 10 centimeters, right? And they tell me the height of the cone is also 10 centimeters, right? They tell me the height of the cone is also 10 centimeters, right? And we're assuming that's a right. It's like a right angle cone. Like this center right here goes straight. It doesn't slant or anything, right? Now, we know that this cone has some water right here, or water or something that's that has a volume in here, right? The volume in here is going to be somewhat filled up to that line right there, which tells us that from here to here, like that, has a depth of 7, right? So from here to here, they're telling me that H, I'm going to call it H, is equal to 7. You guys okay with that? You guys okay with me labeling it H, right? The H is going to be the level of water or volume or whatever that's in there. And right now at this particular point, that H is equal to 7 is what they tell us, right? The depth of the water, oh, it actually says water. So it is water. It is water. So the depth of the water of the cone is 7 centimeters, right? That right there. So given what we have here, let's start writing out some equations that we know here, right? They are asking us how fast is the water level dropping? So this is the water level. H right here is the level of the water. So they want to know how fast that's dropping. So they're asking us to find what is dH dt. That's the start of this problem. You need to be able to know what it is that you're looking for in this problem. And if you're struggling to see how I got the dH dt, right, that's the beginning part. You got to let me know, because that's the first thing that you need to be able to identify is what's the rate that you're looking for? What's the rate that you're looking for? And then you can also, if you don't want to start off with that, you can also just look and see, well, what's the rate that they give you? They give us this rate right here of 2 cubic centimeters per second. 2 cubic centimeters per second. And that is leaking from the cone. That means that it is going out. So it's a negative value. It is leaking from the cone. So I'm going to put that right there. It's a negative 2 cubic centimeters per second. That's how much water is leaking out of there. Can somebody tell me, what should this rate be written as? Anyone have any ideas? 2 cubic centimeters per second. It's something dt. It's something dt. And Monica's got it in there, and Monica's going with dv dt. And that's right, Monica. It is dv dt. Can somebody, it could be you, Monica, or anyone else, someone want to explain to me, how does Monica know that it's dv dt? How does she know that? She's not wrong. She is not wrong. How do we know that this is a volume rate? And Brian's going with the units. That's always a good sign. That's always usually a good indicator of what it is that you're dealing with. And that's right, Brian. In this case, it's cubic centimeters. If it was centimeters squared, I would consider looking at the area, even though we're talking about the filledness of the cone, right? Units usually are helpful for these problems. So in this particular case, since it's a cubic one, it is going to be volume. The other thing that also can help you figure it out is the fact that we're talking about the inside of a cone and how much it's filled. And that's a volume, right? That's what volume is. Volume is the space that's inside there, right? Not like the surface area. That's the area on the outside or the inside of a thing. This is the space that this thing has. Okay, so I have the volume. I have this rate at which the volume is, and I have this height here. My only issue now is I don't know an equation that relates volume with height, because I don't know the equation for the volume of a cube. I'm lying, by the way. I actually do know it, but I'm just making a point here. What should I do if I don't know the volume for a cube? What can I do to help me find out how do I calculate the volume of a cube? I told you guys earlier, right? Oh, man, I don't know what the volume of a cube is. I'm just going to Google this. Yeah, search it up. Equation for, you just type this out, volume of, it's not a cube. No, it's a cone. It's a cone. Volume of a cone. And there's the equation right there. Volume of a cone is equal to pi r squared times the height divided by 3, right? I don't like writing the h over 3 like that. I like writing the 1/3 in front. Give up, Calvin. I mean, you could always, like, I guess. I can't argue that point. You could always just give up. Anyways, let's not be as negative as that, right? Let's just write out this equation here. We know that volume is going to equal to 1/3 pi r squared times h. I like writing the 1/3 in front because h over 3 just makes it messy when you take the derivative. So I like writing it out like this. Now, here's another problem, though. I don't know if you guys can see this or not. I'm going to be able to find out what h is. I'm not going to plug it in right now because I don't want to calculate the volume of this thing. I want to calculate the rate at which the volume changes. So I want to do dv dt, right? But here's the thing. I'm not going to take the derivative right now because this right here, right? I could do this and I could do the product rule, but then I'm going to have to find out what r is equal to, right? Because then if you do this right here and you do the product rule, you end up with 2r dr dt, right? And here's my problem. If I do this and I calculate this, I can find out what r is. That's not a problem. But here's my problem here. I don't know what dr dt is. I know what dv dt is. I know what dh dt is. I have no idea what dr dt is. So that's going to cause a problem for me. If I take this derivative right here, right, you'll end up with, and you'll do the product rule, right? Let's just do that real quick. 2r dr dt times h plus h times r squared. And again, this is not that big of an issue. Derivative of h is dh dt. There we go. So that's not that big of an issue because, we're trying to find out what dh dt is. We could probably find out what r is, right? And we already have what h is. But this is the problem right here. They don't give us a rate at which the radius is changing. And I can't find that. That's not okay. Unless they tell us what those rates are, we can't just solve that if we have more than one rate that we're trying to solve for. I'm already trying to solve for dh dt. I don't have enough memory to solve for dr dt in this problem. They tell us what dv dt is. So this was not good enough. This was not good enough. I can't take the derivative just yet. And that's because of this r. That r in there is screwing me over. So I need to do something that relates, that I can find find out what r is, so I don't have to deal with dr dt when I take the derivative of it. So one thing I can do is find a relationship with h and r in this particular problem. So if you guys listen, this is actually a little bit more difficult than it is to look at, but if you guys can see it, r is right here, right? R is right here, which is half of the distance, right, for this thing. And the radius is changing, of course, and so is the diameter as the height changes. And I think this is kind of neat. Since this right here forms a right triangle right here, it forms these similar triangles as I go down this height. So if I decrease the height by this much, the radius and the diameter also decrease as I travel along there. So it forms this kind of like ratio that they equal to each other. So I get to write this out here, right? So check this out. You ready for this? The distance is going to be equal to the height in this cone, as long as it travels proportionately all the way down. So if the diameter is 10, that means the height is 10. If the diameter is 9, that means the height is 9. If the height is 7, that means the diameter is 7, right? So is the rate 1r per 2h? We don't know the rate, Monica, but we do know a relationship between the r and the h, and it is going to be 1/2. That is right, though. You're on the right track. It is 1/2 because the radius is going to be half the diameter. So you ready for this? Let's go ahead and plug this in. So instead of diameter equaling to h, I could write this as 2r is equal to h, right? This is still true because diameter, right? This is true because diameter is equal to 2 times the radius, right? And then I can actually solve this for r. I can solve this for r by dividing both sides by 2, and I can see that r is equal to h over 2. Now, why am I doing this? This is an old algebra trick, so I don't have to deal with r in this problem. I can replace r with h over 2, right? So when I replace r with h over 2, I get this new equation for the volume. This volume is going to be 1/3 pi, but instead of r, it's going to be h over 2 squared times h. So now I have this new equation that has no r involvement, right? R is going to be in terms of h's there. So I can actually calculate this volume using only the height of the water in this cone, right? So the volume in here is going to be equal to 1/3 pi times h squared over 4 times h. Simplify this out, and I have here now the volume is equal to, let's see here, 4 times 3 is 12, so it's going to be 1/12 pi h cubed. Pi h cubed. When you do this extra work and you get into this part now, we don't have to worry about dr dt, and we also don't have to worry about r, right? How do I know that I should have done that? I didn't. I tried it at first to do it with the equation that I looked up online, right? And then I saw that, okay, I did the product rule there, but then I noticed this issue right here. that dr dt is not something that's easy to find in a problem, right? That dr dt is not something that's easy to find in a problem. So we had to do a little bit of work to get that in there, okay? So that's going to be that one right there. It's not done, by the way. We're far from done. So now I have an equation. I did all this work to get to this equation where the only things I'm relating the two is the volume and the height, and that's what I really wanted to get to. Okay. All right, let's go ahead and take the derivative of this guy with respect to time. Right, d dt, and over here I'm going to end up with dv dt is equal to 1 over 12 times pi, and then I'm going to do this derivative right here, 3h squared, right, dh dt. Please don't forget that chain rule, right? Please don't forget that chain rule. That is very important that you know that the derivative in there of h cubed is going to be 3h squared, but don't forget the dh dt. Okay? So we're almost done. We're almost done. You ready? You ready for this? We know what dv dt is. dv dt is equal to -2. We also know what h is. H is equal to 7. And that's the only variables that we need to find so that we can solve for dh dt. You see that? dh dt is going to be the only variable there, right? I know that you're like, knock me, there's a pi, but pi is a number, right? That's going to be in there. So we're just going to go ahead and plug everything in here. So dv dt is going to equal to -2 centimeters cubed per second, which is going to be equal to 1 over 12 pi times 3 times 7 squared times dh dt. Times dh dt. All right. Solving this out, you got to go ahead and use your calculator for this, right? Combine like terms and multiply stuff out here. I believe 7 squared is 7 squared is 49. 49 times 3. Why am I doing 49 times 3? Knock me. Your mental math is weak. 3 over 12, that's going to be a 4 right there. So I'm going to end up with -2 equals to 49 over 4 pi dh dt. Multiply the 4 over, you're going to end up with -8. Divide by 49, that'll be in the bottom right there, and divide by the pi as well, and that's what your answer is going to be. It's going to be -8 over 49 pi, and that's just a calculator, right? It's just going to be a calculator. Let's just plug that into the calculator right here. You have your -8 over, of course, put that in parentheses, 49 pi. Can you guys make sure I did this all right? I kind of rushed through that. Make sure I canceled stuff out correctly. I hope I did. The 3 and the 12, that cancels to 1 over 4. 7 squared is 49. I think that's going to be right. And then we have here our answer, which is going to be -0.051968961961 is equal to dh dt. What do you guys think the units are for this one? What do you guys think the units is going to be? The rate at which the height is changing is negative, which makes sense because if the volume's leaking, the height is decreasing, so it's going down, it's getting lower. So the rate being negative makes sense. But what's the units for this one, guys? What is the units for this problem? If the volume is cubic centimeters per second, what's the rate at which the height is changing at? Anyone got any ideas for the units for this one? What do you guys think? What is it? No one? No one got any ideas? Centimeters per second. That's right. It is centimeters per second. That's your answer right there. There you go. That's the problem in a nutshell. It's a little messy, but I'm hoping you guys are realizing, right? It's not too bad if you ever are stuck on these things, right? Just get the equation down that relates to the stuff that you're dealing with. Take the derivative with respect to time, and then just start plugging in what you know, right? With that, you should be able to do your homework now. And I'm going to go ahead and bring up your homework real quick. Your homework is going to be on Delta Math. Some of you guys have already seen it and started it. Some of you guys did not know that I put it up already. I put it up last time, but That's not, there we go. Calculus, here we go. And it's a total of 7 problems. I did not put on penalizations for this because it's not your review. It's just regular homework. But yeah, so they have these problems on here and they will have examples that you can take a look at. They don't draw out the picture, but I really suggest you guys draw it out. So in this particular case, you're dealing with rectangles. I draw out the rectangle and then list out that they're dealing with, it has a length of 11, has a width of 4. The length is decreasing by this amount. The width is growing by this amount. What's the rate at which the area is changing? So this one, they actually tell you 2 rates. They tell you the rate at which the length and the width is changing, so you could plug in those values. You see that? And that helps you figure out what is the dA dt going to equal to. Oh, and I do have all the videos unlocked, so if you want to watch the videos, you can, if you guys are familiar with it. I think some of you guys have told me that it is helpful to have this video there. So it should be unlocked for you guys. If you still don't know how to do it, you can watch that video. And if you still don't know how to do that, how to do these problems, you got to let me know. I will be in my office hours today from 1 to 2. All right, guys. I'm going to call it there. You guys okay with this? Does this make sense here? Hopefully it does. And if not, let me know still. There's rectangles, triangles, and then there's these 1 formula, 2 formula ones. These will be a little bit different. So, there'll be different shapes. Sometimes they'll be circles, sometimes they'll be cubes, sometimes they'll be cones. There'll be various shapes that you're going to be dealing with. So just keep that in mind. Other than that, I was grading your quizzes. There's a couple of you guys who left it blank, but no one came to office hours to try to fix that. So let me know if you didn't take the quiz or if you didn't finish the quiz. Those are going to be put into your progress reports at some point. And also goes towards your final grade. Aside from that, I'm going to have your study guide up and running. So you're going to have your Delta Math extra credit study guide up and running before the end of today. And then I'll have your study guide for the chapter before the end of the week. And then your test is going to be next week. I'm thinking test next week on Thursday. You guys okay? So test will be next week, 1 week from today. Next week on Thursday. We'll go over and review stuff next week on Monday and Tuesday. All right, guys. I'm going to wrap it up there. Hopefully, if you have questions, you'll let me know. If not, right, just get working on this homework and the study guide and get ready for your test next week on Thursday. All right, guys. And that being said, we do not have a 3-day weekend this week. All right. So enjoy your weekend. It's going to be a little bit shorter than what we've been doing for the past couple of weeks. But I'll see you guys on Monday. All right. Have a good weekend. Stay out of trouble. Stay out of jail. Don't get pregnant. I'll see you guys later. All right. Have a good one.